In this video lecture, we look at algebraic manipulation known as polynomial division. Now, in terms of algebra, you were exposed to algebra for quite a few years of your high school, beginning in some cases at the grade 8 level. And there you introduced a variable to represent some quantity. At this stage of your mathematics exposure, we need to realize that equipping you for self-study also means getting used to notation and mathematical syntax so that you could pick up any particular textbook and analyze it yourself. Hence, we're going to start off with the definition of a polynomial. So the definition is a polynomial is any function of the form, so it's a function, f of x, a in x to the power n, a n minus 1, x to the power n minus 1, and so on, until you get to a1 x plus a0, where n is a non-negative integer. Now, these are terms that you need to get accustomed to. Mathematics textbooks at higher level, tertiary level, have to be strict in terms of indicating whatever it is they wish to communicate. So this is a non-negative integer. And look at where n is. It's in the index of x. And what is an, or an minus 1? Well, these are simply real numbers. In other words, some sort of constants. 2, 1/3, negative 0.1. But an not equal to 0. N is known as the degree of the polynomial. So now I ask you, if you look at that, which is essentially the definition of a polynomial, have you come across it before? Think about it. Have you? But of course you have. You've been dealing with all the time with mathematics, the algebra section. Look at this. That is a polynomial. Of what degree? Third degree. So if you have to equate it to the definition, the n is equal to 3. The an, in this case, is 2. So if the highest power is 3, we notice that the very next term is an index 1 less. And the next term is the index 2 less than the highest power. So if we look at this polynomial, if the highest index is 3, then the next index must be decreased by 1, n minus 1, which is 2. And then 1. And then we should have here, can you tell me what we should have? If I had to put an x over here, x to what power? That's right, it should be a 0, where x to the power 0 is equal to 1. So have you come across polynomials? Absolutely. Your quadratics, x squared minus 7x plus 8, they are simply polynomials. X cubed minus 1, they are all polynomials. I can go on and on and on. You don't have to have all the terms. All the terms could be missing, which means If I give you a term such as that, 2x to the power 5 minus 3x squared plus 7, look at this polynomial and tell me the highest power, so the degree of this polynomial is 5, so the degree is 5. Then the next term below that should have x to the power 4. What do you think is the coefficient of x to the power 4? If you don't see it, that's right, it is absolutely 0. So these are polynomials. Now we can look at how do we go about dividing polynomials. So if we have a polynomial p of x, it's divided by another d of x. Then the following is true. The polynomial divided by d of x is equal to q of x plus r of x divided by d of x. Or another way of putting that, p of x is equal to q of x times d of x plus r of x. Now, these are terms that you've come across way in your schooling career, even before you started algebra. P of x is the dividend, d of x is the divisor, q of x, quotient, r of x, remainder. Now, let's put this together. Let's go back in time, primary school. If you were given 1,308 divided by 25, you had no calculator, you were told, follow a particular procedure. There are many ways of doing this. And you can debate and look at the different ways that it was taught. But generally, you had to do, yes, what it was called? Long division, eh? Long division. Remember how you wrote that? 25 divided into 1,308. Now I want you to follow very carefully. And the reason is the process that we are developing now is going to be applied in the algebraic analogy of polynomials. So yeah, we're looking at a numerical example. So what did you do first? You took 25, you divided it into 1. That didn't go. 25 can't go into 1. Then you said 25 don't go. Then you said 25 divided into 130. 25 into 130. How many times? Yes, you can. Oh, don't tell me you're taking out your calculator. 25 into 130. 4, 5, 6, 7, 8. Yeah. Okay, 5 times. And you're going to put that answer there. Then what did you do with that 5? You then took that 5, you multiplied it by the divisor. So that was your divisor. This was called, do you recall? The dividend. So at that stage, that's what we know. You multiplied 5 by 25. You get an answer. Do you put that? 5 multiplied by 25. If you're 125, you put that immediately below 130. Now, am I taking long? Yes, I am. Why? Because I'm recalling a process which for me, I probably can put my head on a block here and say, you haven't really done since primary school. Once you had your calculator, did you ever try and do this again? Oh, okay. Once you've done that, then what did you do? Then you subtracted. So over here, You subtract and you get an answer. 130 minus 125, that gave you an answer of 5, whichever way you did that. Now, once you had that, you then repeated the process. And what was that? 25 divided into 5. But now that didn't work because 25 can't go into 5. So what did you do? You brought down the next value, which was 8. So 8 came down and you divided it into 58. That goes twice. 2 times 25 is 50. Where did you put the 2? You placed the 2 at the top. Then you repeated the process. 2 multiplied by 25, you put that answer below, and then what did you do? Subtract again, and you get an answer of 8. Now, I'm going to stop there. I'm not going to introduce decimals to get our form that is required in this case. So we started off with 1,308 divided by 25. What did we call this particular value that we got? That was the quotient. And this was the remainder. So how do we collate this? 1,308 divided by 25 gives me an answer 52 plus the remainder 8. But do I just put 8? No, 8 has a divisor of 25. And there you go. That was your dividend. This is your divisor. That, of course, is your quotient. Oh, sorry, let's go back. I'll put it over here. That is your quotient. And this is your remainder. Now look very carefully at what you've seen here. This numerical example is virtually the same as that. There it is. The dividend divided by the divisor is equal to the quotient plus the remainder divided by that particular divisor. Where did we get the next step from? Very easily. We can multiply this equation, or we can multiply that equation over here by the LCDT of x. In this case, right at the bottom, multiplying it by 25, we get 1,308 is equal to the divisor times the quotient plus the remainder. So there, in essence, is the process that we are going to follow right now. What is important is that you must be able to write your final answer in either of these forms. So what process and what am I talking about? Look at this example that we are going to discuss. Divide x cubed plus 6x squared minus 2x minus 5 by x plus 5. And we are going to do this by polynomial long division. You'll find in many of the slides what happens is when I write on the screen and I happen to touch it, then a whole host of things may just appear. So I'll just have to go in and out. Hopefully it doesn't happen too often. So long division. Now, how do we go about doing long division for polynomials? So there's my polynomial. That's my divisor. I can call that polynomial the dividend. And this is my divisor. That is my divisor. Dividend and divisor. We're going to follow the same process as we did in the previous slide. So take the divisor into the dividend, and we're going to follow that notation. So I'll make a division sort of symbol. That's my divisor. And then make a note here. You must put this in decreasing powers of the polynomial. In other words, if that's the polynomial, you double check that it's set out in decreasing powers. So this is a polynomial of degree 3. The next one must be 2, then 1, and then of course the constant. I'm going to call the one that does not have x the constant. So in this case, -5 is the constant. Now, very important. If you are given a polynomial and one of the terms are missing, leave a gap in the long division process. So in this case, my dividend is x cubed plus 6x squared minus 2x minus 5. And I haven't left any gap because I have all the terms starting from the highest degree, 3, then 2, then 1, then minus 5. Now we're going to follow the same process as we did before, except this time we are going to divide the variable, the highest power of the divisor. In this case, the highest power is 1. So always arrange the divisor so that x is first, even if it is a negative. Then you divide x into x cubed. Now that is simply saying, oh, there you go again. That is simply saying x divided into x cubed. And what's your answer? Squared. And where do you put the answer? Just like you did in the numerical example, you'll put that at the top. So that is x squared as part of the quotient. And like your numeric example, what did you do with the x squared? You multiplied. But this time, you will multiply x squared by x and x squared by all the terms in the divisor and place those answers beneath the appropriate like terms. So x squared times x, that gives you x cubed under whatever term x cubed is. X squared times 5, that gives you plus 5x squared. Now you subtract. So subtract those. X cubed is x cubed. That gives you 0. So now we are going to subtract over there. And please notice that these arrows are inserted as we go along with the lesson. So if you view the PowerPoint slide by slide at a later stage, it will show you all the arrows. However, if you play it, then you will see the process as it unfolds. So I said x cubed minus x cubed, that gives you 0. 6x squared minus 5x squared. Now do be careful, because in some cases you will be subtracting minus times a minus minus. Watch the sign changes. So this is straightforward. 6x squared minus 5x squared, that gives you a x squared. Maybe it would be wise to simply erase, or don't write 0 over there at all. Just write on the terms that remain. Now that we have that, what do we do next? Then we simply repeat the process. Now, at this stage, you could bring down the next term. For instance, minus 2x and minus 5. I'll just bring down the minus 2x. In other cases, you may not have to bring anything down. You simply have to divide once again. So now we repeat the process, x into x squared. And what does that give you as an answer? That gives you plus x. So put the correct sign plus x. And what do you do with that plus x? You multiply, you repeat x times x, x times 5. Now I'm not going to do any more arrows. What's happening now? X times x squared under the correct like term. X times 5, that gives me plus 5x. And then again, subtract. Now watch your signs. X squared minus x squared. So we are subtracting x squared minus x squared. That gives me 0. Minus 2x minus a positive 5x. What does that give you? So it's negative 2x minus a plus 5x. Using multiplication of signs, negative 2, negative 5x. Sorry, that's negative 2x, negative 5x, and that gives you negative 7x. So we should place negative 7x there. After the subtraction, bring down the next term, repeat the process. X goes into minus 7x. Watch the sign now. That will give you minus 7. What do we do with the minus 7? Multiply out both the terms. Minus 7 times x, minus 7x, minus 7 times 5, negative 35. Subtract here, and check the signs. So this one will be negative 5. This will be negative 5, negative 35. Yes, and what will the answer be? That's going to change your positive. Negative 5 plus 35 gives you 30. And that would be the answer that we will write here. Now notice at this stage you can't go any further because x cannot be divided into 30. So what does that mean? That simply means the process is now done. It's complete. In other words, we have x cubed plus 6x squared minus 2x minus 5 divided by x plus 5. So that's your dividend. That's the divisor is equal to the quotient x squared plus x minus 7 plus the remainder of 30 divided by the divisor x plus 5. And immediately after that, what I would suggest is you also write it into the correct form or another form, x cubed plus 6x squared minus 2x minus 5 is equal to the divisor times x squared, the quotient, plus the remainder. So there we have, if we just go back, there we have the two forms that I was indicating, this one and that one, the p of x. So in our case, we'll have that is the p of x, that x plus 5 is your divisor, that is your quotient, and that is your remainder. Okay, that is a first example. That in essence is long division. So the only thing you can come across now is more and more examples. This one I have completed. You can go through it We divided. There's our dividend. But why have I chosen this particular one? Notice the divisor. That's my divisor. And the highest power of the divisor is x squared. And look at all the terms in the long division bracket that we've used. Highest power 4, then 3, then 2, then 1, then the constant. And then we just divided the highest power of the divisor, into, okay, that would be incorrect there. Just let me erase that. We'll divide the highest power of the divisor into 2x to the power 4. That gives you 2x squared. And by each term and place it in the appropriate like term space beneath the terms at the top. Do the subtraction. In this case, I brought down all the terms up to 12. It doesn't make any difference. You're going to repeat the process. X squared into 7x cubed. Put the answer at the top. Get subtract. And then again, x minus 4x squared. There's your remainder. So there's my dividend. My polynomial is equal to my divisor multiplied by my quotient plus the remainder. Now, just for your info, how is this going to be sort of displayed in or asked? How do you go about asking questions of this nature in tests or examinations? Well, consider that I could give you this entire dividend and the divisor, and then instead of giving you the quotient, I would say something like this: ax squared plus bx plus c plus d, and then ask you to find a, b, c, and d. So be careful how a question like this could be phrased. Now, I want to look at another manner in which we can do division, and that is something that some of you have come across: synthetic division. In other words, it is still a technique of long division, but compressed into a very, very short form. And this is important. It is only used, we can only use it when we have linear divisors. So for example, example 1, divide 2x cubed minus 9x squared plus 13x minus 12 by x minus 3. And there the solution is displayed. Now, obviously, when you just see arrows going, red arrows going down, then the black arrows going from left to right, and you have numbers, all where do all those numbers originate? So let's see. If you notice that the divisor is a linear, now what do I mean by a linear divisor? When the coefficient of x is 1. Think of a straight line. Think of the equation of a straight line. What's the equation of a straight line? Y is equal to mx plus power of x, 1. That's why we tend to call linear any expression in which power of that variable is 1, we will call it a linear expression. So here we have a linear divisor of x minus 3. What we do is the following. We equate, firstly, we equate that divisor to 0. In other words, put x minus 3 equal to 0. What value of x makes the divisor 0? In this case, x is equal to 3. All right. So how do I get this? We start at the top. Or let's draw the table first. I want you to draw a table of this nature. A vertical, then a horizontal. On the right-hand side of that vertical, you put in the coefficients of the dividend decreasing powers. So if I take the highest power x cubed, the coefficient is 2. The next power x squared, the coefficient is -9. The next power x. Now you take those coefficients which are written in decreasing order and you write them down. 2, -9, 13, -12. On the left-hand side of this vertical line, you write down the value that made the divisor 0. So that's a 3. Now, if I look at this process, the vertical line, the red line means and the line from side to side, multiply. Right? Remember that. So where do we start with first? We start with the 2 and we add down the column. Well, there's nothing underneath the 2, so it's 2 plus 0 that gives you 2. Then we go across. We take the 3, multiply that 2 to get an answer which is 6, and we put that answer under the next value, 6. And now we simply repeat the process. We add -9 plus 6, -3. What do I do with the -3? Now I'm not going to draw the arrows anymore because they are on the left-hand side solved for you. 3 times -3 gives you -9. What do you do there? You subtract 13 minus 9, that gives you 4. Then you multiply 3 times 4, that gives you 12. -12 plus 12, that gives you a 0. Therefore, now where do these values go? Well, very easy. You got 2x cubed minus 9x squared. Remember, this is the dividend. There's your divisor. Now, if you divide x cubed by x, then the quotient must have an x squared term. Think carefully about that. To get an x cubed, if I take an x, I have to have an x squared there. So you have to figure out, according to the highest power, what to write here. In this case, it's an x squared. That means the next term must be an x, and then you're going to have a constant term, and then you will have your remainder. And these 3 values are the values that you see here. 2x squared minus 3x plus 4. That is your remainder. And what's your remainder? 0. Do you need to write the 0? Not at all. That is your synthetic division. Now, if you are asked to do long division, or you're asked, for example, in this case, divide x cubed in example 2 by x plus 1. You've got a choice. You can do long division or you can do synthetic division, whichever you prefer. There are some cases, as in the example that I've discussed previously, where, look over here, the divisor is x squared. You can't do synthetic division in that case. You have no option but to do long division. And make a note of this, that when the divisor is higher than 1, x squared, x cubed, when the divisor is a power higher than 1, then you got no option but to do long division. What about here? Well, that power is 1, so I can do synthetic. Let's try synthetic. Let's do synthetic, okay? So my solution, If I'm going to do synthetic, I'll draw a vertical line, draw a horizontal line, and then put in the coefficients. There's a 1, so there's a 1, there's a -3, and there's a 1. And then you realize, hang on, something wrong, eh? Because I should have a x cubed, then a x squared, then a x, and then the constant term. But there's no x squared, so what should I do? That's right. In other words, I've done this incorrectly. I've got to ensure that in the place of the x squared, I put a 0. The coefficient of the x squared is 0. Then the -3, then the 1. Be careful of that. What you put on the left of that vertical line, why must I put -1? Because I take the divisor. What value makes it 0? X plus 1 equal to 0 minus 1. And that's also by inspection, you can see -1. Now I follow the process. 1 plus 0. Oopsie. I have no idea what happened there. Just let me try and erase that. There you go. So this is an arrow. Maybe we should leave the arrow out. I think you agree with me. Let's just leave the arrow out because it'll be a bit more confusing. 1 plus 0, that gives you 1. Then I cross multiply -1 times 1. Put that answer under the next term. What do? Add 0 and -1 gives you -1. -1 times the -1 gives you +1. Then -3 plus 1 is -2. Then -1 times the -2, that gives you 2. 1 plus 2 is 3. Therefore, now it is important that you finish this correctly. X cubed minus 3x plus 1 is equal to the divisor, which is x plus 1, multiplied by the quotient plus the remainder. Now, immediately you should be able to see that is remainder plus 3. And when the highest power x cubed is divided by x, that means this quotient must have a x squared, a x to the power 1, and a constant term. And these three values are the coefficients of the three terms in that particular order. There is your answer using synthetic division. What you can do is check this solution by using long division. Okay, that's sufficient examples. I'm pretty sure to get you into the skill of completing polynomial division. Now let's get into something that you are quite familiar with, or you should be familiar with, a remainder theorem. The remainder theorem states that if any polynomial, now remember, start thinking, if it's any polynomial, p of x is divided by x minus m until the remainder is independent of x, then the remainder is p of m. Now, what we are looking for here is without doing long division, would I be able to find the remainder, which in many cases becomes important where we only need to know the remainder. And this we can do by using the remainder theorem. So if you have a polynomial, for example, there's our polynomial, and you want to divide it by a linear divisor until the remainder is independent of x. And what do I mean by that? Let's just go back to our example. If we do long division, look at the remainder. Does it contain a x? No. So the remainder is independent of x. Then it says all you have to do is do this function p of m. And where does the m come from? Right from the divisor, x plus 1. Put that equal to 0. Solve for x, and there you get x equal to minus 1. Take that minus 1, substitute it for the x, so it will be minus 1 cubed minus 3 times minus 1 plus 1. There is our remainder without having to do long division. A variation of that remainder theorem is the factor theorem. The factor theorem states that if you take a polynomial, divide it by a linear divisor such that the remainder is now 0, then that particular divisor is a factor. In other words, if we get 0 over here after substitution, then we know it's a factor. So let's take this example. My divisor is x minus 2. What makes that 0? 2. I substitute. Now I've just introduced f of x. So I'm going to make this here f of x. And wherever I see x, I replace that by 2. So it's 2 cubed minus 4 times 2 squared plus 3 times 2 plus 2. Let's see what happens. 2 cubed, that's 8. 2 squared is 4. 16. 3 times 2 is 6 plus 2. And what does that give you? 0. So this factor theorem states that when you get 0, therefore that divisor x minus 2 is a factor. Now, do you recall when you use this? Yeah. Remember when you had to sketch cubic graphs? You had to factorize it. Then all you did was just substitute numbers until it gave you what? That's right, until it gave you 0. And what theorem were you using? The factor theorem. You are using the factor theorem. Okay, let's look at our applications. So here we are factorizing quartic polynomials. In other words, all we want to do is solve for an equation, right? We want to solve for an equation, but it's higher than the cubes that you are familiar with. So we'll just go to one higher than that, the quartic or 4th degree polynomials. You can do the same for 5th degree, 6th degree, and you follow probably the same process. Now here I have an incomplete solution, but I'm just going to do this quickly for you. Let's see in my solution. So we want to factorize that. So I said let f of x equal to that. Then by trial and error, we started substituting. Plus 1, remember you have to use factors of the first and last term, but in this case we use the last term. We can go plus minus 1, plus minus 2, plus or minus 3, and so on until we get 0. But we are fortunate. We notice that 1 works immediately. Therefore, if I take the process and go back, in essence, then the factor is x minus 1. Then we're going to use synthetic division to get this answer here. So how do we do that? Very quickly. Let's see. So I'm going to use synthetic division here. So that step I'm showing you here. My divisor is x minus 1. So I'm going to put 1 on the left-hand side of the vertical line. On the right-hand side, I put all the coefficients in decrease in order. So that's 2 minus 1 minus 8, 1, 6. Do you remember what to do? You're going to add the 2 plus nothing gives you 2. then multiply 1 times 2 is 2, minus 1 times minus 1 plus 2, that gives you 1. 1 times 1 is 1. That's going to give you minus 7. 1 times minus 7, minus 7. Then 1 times 1 minus 7 is minus 6, and 1 is minus 6, gives you minus 6, and that gives you 0. Therefore, this can be factorized into the divisor, x minus 1. And because the highest power was a x cubed, well, let me just rather do this, because in terms of writing out our solutions, we must be extremely careful in writing a solution that an examiner or someone else that reads it knows exactly what's happening. So I did the synthetic division by looking at 2x to the fourth minus x cubed minus 8x squared plus x plus 6. And that will be equal to my divisor multiply. Now remember, this is x to the power 1, and that's x to the power 4. So this must be an x cubed. I have to have an x squared, an x, and the constant term. So I must have 1, 2, 3, 4. There you go. 2, 1, minus 7, minus 6. 2 plus 1, minus 7, minus 6, and no remainder, which you see exactly the same here. Now I want you to repeat the process for that. Just do that one by itself. And you will get, in that case, you'll get x plus 1, 2x plus 3, and x minus 2. Okay, that brings you to the end of this video.